Yes, hello. Hello.
Hi, hello. Good evening, all of
Hello,
you.
Magesh.
Yes, sir.
Yes. Shall we start?
Sir, wait a minute, sir. We are waiting for the speaker.
Okay. Sir, good evening, sir.
Good evening, sir.
Yes. Yeah. Yes, sir. Sir? Oh, oh, okay. Okay, sir. Okay, sir. Okay, sir. Okay, sir. Okay, sir. Okay, sir. Okay. I'll inform, sir. Good evening, participants. I request to wait a few more minutes. The session will start shortly.
Good evening to the participants. I'm Dr. KV and Rao, head of the Department Mechanical Engineering and convener of this program. So right now, there is a power failure in the area where the resource person of this session is staying. So we are trying to resolve that issue. So kindly bear with us for 1 or 2 minutes. Thank you for your cooperation.
Jilrasan sir, sir has come, sir.
Yes, sir. Yes, sir. Yes, sir. Shall we start?
Yes, sir.
Yes, sir. So there is a problem from my side. In my area, it is likely to rain.
Yes, sir. Yes, sir.
There was a power cut from the last 20 minutes. Still, I'm expecting just as if it would come. But as I could not expect it in the right time, just I started with the mobile data.
Okay.
Let us see that we can stream the session now.
Yes, sir. Yes, sir. Yes, sir.
There may be a little. Please go ahead.
Yes, sir. Good evening, sir. I would like to introduce our today's session guest. Let me introduce our guest today in this wonderful session. I am very much proud to introduce today's evening's guest. That is our beloved principal, Dr. Naveen Kilari of our Vemu Institute of Technology. Our today's guest has graduated BTech, MTech, and PhD in mechanical engineering. His area of interest are like thermodynamics, heat transfer, operational research, NBA, NAC, ISO accreditations. Further, he is an inspirational speaker who teaches youngsters how to turn knowledge into results. In last two decades, he has traveled in and around our nation and closely associated with a variety of educational, administrative research and professional bodies. He has designed and delivered career-oriented 6-month diploma courses like DESD, DSSD, DABC, conducted across 8 CDAC centers. He has involved actively coordinating and managerial level in a wide range of activities like general and academic administration and CET convener and admissions, curriculum development and delivery, training and placements, NBA, NAC, autonomous ISO accreditations. He has authored on the following topics. Organization development, training and development, business research methods, student success mantra for excellence in higher education. He also published about 20 research articles in the peer-reviewed reputed international and national journals and also guided to PhD scholars. He is also executive director for 2 international journals. Further, he has completed 3 training projects funded by DIT, Government of India at CDAC Hyderabad, and also he designed and conducted corporate training, FDP, seminar, workshops, skill development programs for the benefit of corporate. He also got many awards, recognitions, and distinctions from various councils and organizations. Once again, I give warm welcome to our beloved principal to give a talk on technology trends and industry in 4.0. Thank you, sir. Thank you.
Thank you, sir. Thank you for your nice introduction.
Thank you, sir.
I welcome all participants. Sorry, there is a little bit delay, some 4 minutes. I joined the meeting very lately as there was a technical, there was an electrical supply failure in my area. I could not able to join on the right time. So I made some alternate arrangement. Even I'm a skeptical up to what extent my laptop battery would support and up to what extent my mobile data would support for the streaming of this session. Let us pray for the good for the next 50 to 40 minutes, 50 to 55 minutes. So with this, just in order to save the data and just I'm stopping the video. Just please bear with me only by looking at the slides. So now, as one of the sessions in this emerging technologies in the mechanical engineering, we thought that to have one session. Before starting my session, let me appreciate the efforts of my team, Dr. KVN Rao sir, Dr. Ejilrasan, Uma Mahesh Babu, and other faculty members for organizing such an excellent 5-day workshop or 5-day faculty development program on emerging technologies in the mechanical engineering. I personally thank and appreciate the efforts of each and every faculty members of the mechanical department for organizing such an excellent faculty development program. And also I am thank the HOD, Dr. KVN Rao sir, for giving me an opportunity to take one session on the technology trends and the industry 4.0. So with the permission of my HOD sir, just I would like to proceed now. So
Sir, please carry on, sir.
the brief agenda of this today's next 50 to 55 minutes is technology trends, industrial revolutions, industry 4.0, technology levers of industry 4.0, Why Industry 4.0? Industry 4.0 and the smart factory. Industry 5.0 also I would like to touch upon 1 or 2 slides on the Industry 5.0. And also we are going to discuss a little bit on some examples of how the Industry 4.0 or the 5.0 is going on. Here, the Industry 4.0 or 5.0 is just more than just a flashy catchphrase. It is the convergence of the trends and technologies that promises to reshape the way the things are being made. So as it is as the Industry 4.0 or 5.0 is the convergence or the confluence of the trends and technologies, just for the next 20 to 25 minutes, I would like to focus a little bit on from the ancient days, how the technology has been evolved. That means the evolution of the technology, right from the ancient times, right from the copper, bronze tools, up to the so far modern information communication tools. I use the word the copper, stone, bronze tools, which were used by our ancient Homo sapiens. From the copper, stone, or stone tools to ICT tools, information and communication tools, how the technology has been evolved, what are the industrial revolutions. I thought it would be good to start from the basics. So that's why and more in this presentation, it has been prepared from a wide range of sources, including the books, websites, web pages, research articles, and some white papers for the Confederation of the Indian Industry, CII, and the NASCOM. These slides and this presentation are intended for purely educational purpose only. So if we start with the technology evolution, the beginnings of the engineering, right from the 6000 to 3000 BC, if we see the technology trends, which were popular for the tools, which were made by stone, or just please permit me to have some the stone, copper, and bronze tools that were made. The people also discovered the methods of producing the fire at will. People built houses, cultivated plants, domesticated the animals. Mathematics were used. Information was written on the papyrus, parchment, or clay tablets. So in those days, the technology trend was the tools and materials, which were made by stone, copper, and bronze tools. Slowly, as we moved during the same period, 6000 to 3000 BC, major engineering projects. So here I am using the word major engineering projects, and I am referring the animal, water, and wind-driven machines. In those days, in those 6000 to 3000 BC, this windmill, the wheel which was run by water, the invention of the wheel and axis, the yoke to have the coordination between two animals, it itself is a major engineering project in those days. So that means the tools and materials from this age of 6000 to 3000 BC. Just slowly, if we move towards this 3000 to 6000, from 3000 to 6000 BC, if we see the 23,000, the Egyptian pyramids, 23,000 building stones, each weighing 2.5 tons, used to build the Great Pyramid. Outstanding examples of the engineering skills in the land measurement and the building layout, and also the irrigation systems. During this period also, the technology trend is the tools and the machines. Here, if you see the tools and materials during 6000 to 3000 BC, the technology trend is the tools and materials. Just as we slowly move to 3000 to 600 BC, the technology trend was tools and machines. Machines of this kind to lift the water. That means the irrigation systems. And slowly, from 600 BC to 400 AD, if we see the engineering in Greece had its origin in the Egypt. Here, the better known for the intensive development of the borrowed ideas than for the creativity and invention. During this period of 6000 BC to 400 AD, the Socrates, Plato, Aristotle, Archimedes, who are popular for the physics, and the Archimedes for the mathematics. We have seen the Archimedes principles and all those things. So therefore, the engineering in Greece had some history in the form of the Archimedes water screw, crossbow catapult. Here, the Archimedes principles and all these things came into existence. slowly the technology moved from the tools, materials to machines to the principles. Slowly, as we move towards the first to 16th century, from the history books we read that it was the dark ages to much improvement in this from the first to 16th centuries. But however, the word engineer began to appear. That means the engineer, the Latin word, means to design or devise. Animals and water wheels began to replace the humans as the power source. Arabs were developing the paper making, chemistry and optics, and also sugar refining, soap making, and perfume distilling became part of the culture. Chinese were developing the clocks, astronomical instruments, the loom, and spinning wheel and gunpowder. Though it was considered as the dark ages with respect to the science, but still, there was a replacement of the human effort by various animals and water wheels, and also slowly the industrialization started taking place. Now, this first 16th century, it was considered as the dark ages towards the science. That's why during the 17th and 18th century, which was considered as the revival of the science, the developing of the industrial age. James Watt, with what all we are very familiar. Steam engine for textile mills, iron furnaces, rolling mills, and other industries. Hargreaves, Cotton, Jurgen developed spinning weavery. Van Musenberg developed a device to hold a static electrical charge, now which was called as the Leyden jar, the forerunner to the capacitor. Electronics engineer are well familiar about this. And Galvani, the principles of electrical conduction. Volta, principles of the electric battery. And coming to the modern science, the 19th century, Ampere confirms the flow of the electrical current into the science of the electrodynamics. Michael Faraday found the means to generate electricity by moving a conductor through a magnetic field. J.C. Bose, they demonstrated the transmission of electric signals to the space. Of course, the Marconi was awarded a patent for the same achievement a year later. Henry Cott developed a method of refining the iron. Once again, the James Watt, he refined and produced an efficient steam engine during this around 1740 or 1780. He developed the James steam engine. Was the first version of this steam engine was invented, but after that he refined the same. And also at last the good iron for machines and power plants to operate the machinery. So here slowly the technological trends from the tools, materials, machines, principles, and also the methods of doing of producing the various products. Now slowly as we move towards the 20th century technology, Henry Ford, mass production of the automobiles, Thomas Edison and Lady Forrest developed the electrical equipment and electron tubes, which started the widespread use of the power systems and communication networks. Wright brothers, they developed the powered aircraft. Einstein, E equal to mc square, and also the first nuclear pi was developed during this 20th century in the University of the Chicago, and also the communication satellites started their journey, by means of which now we can handle more than half of all the telephonic, television and audio network program distribution. So here also the technology trends, tools, materials, machines, process and methods. So from this, if we see if we have a little bit throughout scanning of this entire developments in the technology, 6000 to 3000 BC, the technology trend was tools and materials. Of course, the materials are copper, bronze, iron. 3000 BC to 600 BC, tools, materials. Slowly we develop iron and machines. Here, from 600 BC to 400 AD, tools, machines and principles. After that, all you know very well. In addition to the tools, materials, machines, here the materials, slowly iron with the carbon, which formed a steel. It changed the entire original equipment manufacturing process and methods. Now, broadly, tools as technology, materials as the technology, machines as the technology, processes as the technology. Processes means process that use technology such as the machines, and computer software is also a process to make something or to solve a problem. So slowly, these are the trends in the technologies in those days. And now, for the betterment of this thing, if you see, better products engineered with the technology, if by means of the gravity, by means of that we developed the ballpoint pens, and by means of the pressure cooker, the closed vessel, and at the high pressure, the boiling point is high. All you know, the mechanical engineers, from open cooking to the closed cooking, it works on the principle that at the high pressure, the boiling point will be high. At the higher boiling points, we can cook the food easily. And also from the open smoky burning to the liquid burning, mechanical energy, and also the electromagnetic waves from this old good old phone to the latest smartphone with wireless charging. All this was made possible through the development, through the invention of the new technologies. And also, if you look at the technology in India for the past 50 years, if you see, almost from 1970, the Green Revolution, Operation Flood, slowly aquaculture, wind energy, solar power, tidal power, second Green Revolution. And also if you look at the electrical lines from the very minimal to the 50 million lines to the 100 million lines. And also we made a lot of progress in the launching of the various satellites, and also in terms of the nuclear power also, from the Pokhran 1, Pokhran 2, 3000 megawatt nuclear power to 20,000 megawatt of nuclear power generation. And also in terms of the missiles and all these things and hyperplane. So in India, from the Aryabhatta to the hyperplane, we are making a lot of technological advancements even in India. And if we see the recent electronic revolution, the evolution of the computer, from 1950, the very first transistor on any microprocessor, only one transistor. In the next 10 years, 16 transistors on a single single chip. Next, in the next 10 years, 8-bit microprocessor, 4,500 transistors. There was a Moore's law. For every 1.5 years, the number of transistors on a chip. For every 1.5 years, the number of this transistor is the very important element in the computation capabilities of any computer. So as the number of transistors are going on increasing, the computing power of the computer also goes on increasing. Now, if you see in the 2010, I think multi-core processor, here where we started, only one transistor on the microcontroller, on a chip. Now, in a span of the 60 years, in a span of the 60 years, now we are in the 2020, 70 years, just only 70 years. You see, 8 into 10 power 9, 8 into 10 power 9 number of transistors on a single chip, That means the computing ability of a computer, the computing ability of a computer has been increased very drastically. Now it is the age of the multi-core. Now you see, that means now we are celebrating 70 years of the transistor. Now in the 2020, it is predicted that the microprocessors and the GPUs will have as many transistors as there are neurons in the human brain. You see how the technology, where we started with the tool, Stone Age, the tools with the stone, copper, bronze. Now almost we are in the multi-core processors. Now, just in the span of 70 years, the computing ability of a computer has been increased very drastically. Now, you see, agricultural revolution to the industrial revolution, it took 8,000 years. From industrial revolution to the invention of the light bulb, just 120 years. From this to moon landing, 90 years. From this moon landing to World Wide Web, 22 years. From this World Wide Web to this human genome sequence, just 9 years. That means just You see, that means with the rapid advancements in the technology, within the less time period, we are making several changes. We are inventing a lot of things. So time to reach the 100 million users worldwide, time to reach. Now the telephone, 75 years, which was invented in the 1878, the mobile phone, it took just 16 years to reach 100 million years. The World Wide Web, it took just 7 years to reach the 100 millions. If we see iTunes, Facebook, Apple App Store, WhatsApp, Instagram, Candy Crush. Now Pokemon Go, which is a game which was launched in the 2016, it took just 25 days. Which took just 25 days to reach 100 million users worldwide. So this shows how the technology is having the impact on the human life or in the nation development. So if you see, if we look still at the thing, just 1 minute here, the how the computing ability has been increasing, right from the 1900, the first analytical engine, the first computer in the 1900 is in the computer. Here in the around 1970s, the Apple II computer, it was there. Now, if you are going on looking at the computing ability, just I mentioned that the transistor is the major component in the computing ability of a computer. Now, as the number of transistors on a single chip are going on increasing, the computing ability, the number of computations it can make per second are going on increasing. Like that, the prediction is now almost by 2020, we are surpassing the brain power of mouse in 2015. By 2023, the computing ability of the computer can surpass the brain power of the human by 23. By 2045, the computing ability of the computer, it can surpass the brain power equivalent to that of all human brains combined. That means by that time, this whatever the artificial intelligence, whatever we are doing, it can read our brain also. Now, to sum up how the technology has been, what the technological trends or the technological revolutions. The first industrial revolution, which started at the 1771 by the with the Arkwright's mills opens. Here, the new technologies, mechanized cotton industry. The new redefined is canals and the waterways. The second technology revolution, the age of the steam and the railways with the invention of the steam engine by the James Watt, 1829. Steam engines and machinery, railways, iron and coal mining. A new redefined infrastructure is the railways, postal service, telegraph, great ports, city gas. And the third industrial revolution, age of steel, electricity and heavy engineering, 1875. The steel plant opens in the Pittsburgh and Pennsylvania. Then the cheap steel, heavy chemistry and civil engineering, electrical equipment manufacturing. Here, during the third technological revolution, worldwide telephone and telegraph, electrical power networks came into existence. Technological. So here I am referring the technological revolution, not the industrial revolution. The fourth technological revolution, the age of oil, automobile and mass production. The mass production, the mechanical engineers are well aware of what is a mass production by means of the line assembly. First Model T came out of the Ford plant in Michigan. Mass produced automobiles, cheap oil and fuels, refrigerated and frozen foods. Universal electricity, worldwide analog communication, analog here, analog. Those are the days of the analog world. Now we are all in the digital world, major transportation networks. The fifth revolution, fifth technological revolution, not the industrial revolution. This is the fifth technological revolution. Age of information and telecommunications, what we are witnessing now. It was started around 1970s. The Intel microprocessor is announced in the California. The first transistor, what we discussed, 1970 to 2020, almost 50 years. Cheap microelectronics, computers, software, telecommunications, computer-aided biotech, and worldwide digital telecommunications, internet, and email. This is how, by means of all these things, the human life, the human life has changed drastically. All this made the human life better. And also all these technological revolutions have provided qualitative engineering solutions, the qualitative engineering products for the betterment of the human life or for the betterment of the society. Still, if we reach once again, in terms of the, sir, here, whatever I discussed are the technological revolutions. These technological revolutions, if we made them into the industrial revolutions, the broad, we can have the 3 industrial revolutions up to 2000. The first industrial revolution, machine tool industry, textile industry. It has seen the peak during the 1870. The second industrial revolution, automobile, aerospace, computer. It has seen its peak around 1970. Parallelly, the third industrial revolution got introduced. IT industry and bio industry. Almost by 2010, it has seen the peak of the IT industry. So first industrial revolution, second and third industrial revolution. Now in this, if we see here, once again, on the third industrial revolution, if we see from 1990s, what are the major changes in this IT industry? If we see from 1995, the impact of the information and communication technology, 1995, the World Wide Web, hypermedia, interlinked documents, Yahoo, Netscape, AOL, World Wide Web. Next, in the next 5 years, Web 1.0 to 2000, multimedia, interlinked media, Google. It's Google as a search engine which searches all the web pages and whatever the information you require, it is ready to provide. That means all the websites are interlinked. eBay, Amazon. Here the technologies that were introduced are Java, UML, XML, Web 1.0. In the next 5 years, the web, here there is only one-way interaction. Only one-way interaction. The user cannot interact with the computer here. Whatever the information available on the website, we are able to download. We are not able to upload the content here. We are not able to upload the content in the Web 1.0. We are not able to upload the content in the Web 1.0. But coming to the Web 2.0, where the web services, it is interlinked people. Even we can upload the content. Even we can upload the content on our own, in the YouTube, in the Facebook, in the Twitter. It is a two-way. Even from the web server also, they are providing the content, and also from our side also, we are uploading the. Here it is two-way. Even the user also can upload the content into the websites. Next, social media 2, Web 3.0, app technologies. You know, in our smartphones, we are having so many applications, interlinked enterprises. Still, this is Web 3.0, Web A.B, 2015, Internet of Things, Internet of Services, which is generally referred as the Industry 4.0 components, which are called as the cyber physical media. I'm going to focus much on the cyber physical media in the coming slides. Now, 2020 plus, Web X.Y. What is the future media? Now, all they are referring it as the Industry 5.0. Even we will focus a little bit on what is Industry 5.0, how the Industry 4.0 is moving towards the Industry 5.0. Now, with this information and communication technologies, even with this ICT, it is also having a lot of impact on the mechanical industry also. This information and communication technology, already in the previous slides we discussed how from the olden days, from the Greece and from the Romans, how the science and technology has been machines and all those things. From that, now this information and communication technology, by clubbing this information and communication technology with the mechanical technology, it changed the manufacturing sector also. So we will focus on this. That is what the Industry 4.0. This Industry 4.0, as already we discussed, it is the confluence of the technology and the trends. It is the convergence of the technology and the trends. If we look at this, getting the mechanical energy. Now, initially, how we are getting the mechanical energy to grind the cereals and all those things, manual. Here, it is dependent on the manual muscular power. The input is given by the human beings. Here, It is also the dependent on the human being, on the wind power. Wind power. It is also depending on the wind power to have the mechanical output. Here also to get the mechanical output, the input is the electrical energy. It is also dependent. Here, if you see, slowly automated. Though the input is the electrical energy, it is operating on its own, automated, but not collaborative. But it cannot interact with the human beings. So slowly, how the mechanical output, how the output we are getting from the muscular power, from the wind power, water power, from the electrical power. Though the input is electrical power, but it is acting on its own. Now, if we see here, how this here from the 1784, here these are the industry 1.0, 2.0, 3.0, and 4.0. In the end of the 18th century, already we discussed the various technological trends. From the industry 1.0, mechanical assemblies, the first mechanical loom, introducing the mechanical production machines powered by water and steam. It was referred as the industry 1.0 those days. Slowly we moved to the industry 2.0 with the introduction of mechanical assemblies with electronics, introducing the mass production. In 1870, first conveyor belt was set up by the Cincinnati slaughterhouse, and also at the same time, first assembly line, Union Stock Yards in 1870. This period is referred as the Industry 2.0 or the second industrial revolution. The third industrial revolution for the mechanical assemblies, electronics, IT and automation. Electronics and IT for enhanced automation in production. First programmable logic controller in Modicon Company in 1969. Next, mechanical assemblies. For this entire setup, embedded systems, connected IT and interactions with the physical systems. Here these are referred as, these are purely a mechanical assemblies, Here is an electromechanical assemblies, Here this is a cyber physical systems, coming together of digital and physical worlds and the digitalization of the manufacturing processes. Based on this means here the level of complexity is less, as the mechanical assemblies are being coupled with the electronics, then the embedded systems, then the information and communication technologies. The level of complexity also increasing. Now even with your mobile phone, you can able to operate the entire your factory, your lathe machine, your drilling machine, your grinding machine, whatever it is. These cyber physical systems have changed the entire scenario of the manufacturing sector itself. So still, that means the first industry is mechanization, water and water power, steam power. Second one is mass production, assembly line, electricity. The third industry is computer and automation. Now the completely internet and communication technologies. This means what is the cyber physical system? What do we mean by the cyber physical systems? Cyber physical systems are nothing but collaborating the physical systems with the computational elements. What do we mean by computational elements? Which can compute the computing power? Already we discussed it. Web 1.0, Web 2.0, Web 3.0, and Industry 4.0, the smart technologies, the information and communication technologies. That means the cyber physical systems, which are coordinated with the information, computation, communication. These cyber physical systems, they communicate with each other with the Internet of Things. Here the Internet of Things, I will be discussing what is the Internet of Things in the next coming slides. So these cyber physical systems, who's in this? A physical system may be a lathe, maybe a robot, maybe anything, maybe a drilling machine, maybe a welding machine, whatever it is, or a robot, a physical system whose operations are monitored and coordinated, controlled and integrated by computing and communication core. So these cyber physical systems allow us to add additional capabilities to the physical systems by merging the computing and communicating elements with the physical systems. Now, what are the products? And also in line with these cyber physical systems, the output the output is also getting, we are also able to produce the smart products. The Philips lighting, users can control the Philips lighting with a few tube lights via smartphone, turning them on and off, programming them to blink if they detect any intruder, or dimming them slowly at night by using your smartphone. And Meditronics implanted digital blood glucose meter connects wirelessly to a monitoring and display device. And this one stream discovered calories burned, movement intensity, heart rate, and other data. Directly it comes to your mobile phone. And this drive product systems put sensors and connectivity in the tennis racket handle. Even not only this, even in the cricket, in the stumps, we are keeping the sensors and the cameras. By using that, we are able to get the ball speed and everything. We are able to, that means completely the smart stumps in the cricket. So these are all the smart products. So in order to produce these smart products, the smart factories are required. Smart factories, that means this smart, what are the various components of the smart factories? They start with the major components of the smart factories are embedded systems. These embedded systems are the smart sensors. Sensors already the previous speakers have focused much on the various types of sensors used in the robots and all those things. So that's why I'm not focusing what are the various types of sensors here. So by using the smart sensors, smart systems, these smart systems are connected with the communication devices. Smart systems are connected with the communication devices, which are called as the cyber physical systems. This cyber physical, so many cyber physical systems collectively are called as cyber physical production systems, or a smart factory, which are having several cyber physical systems. That means various embedded systems or smart systems which are connected with the communication. By means of these communication devices, these various facilities, they interact on their own. Each device, each system, each physical system, this physical system will interact with this physical system on their own. This is the added advantage of the cyber physical production systems. Now, technological push, smartphones, smart homes, smart cars, smart factories, from technology push to the market pull. Now, what are the technology levers in this industry 4.0? If we look at the broad technology levers, the big data or the data science, data analytical capabilities. That means because of this communication devices are connected with these smart sensors, they are producing a large amount of data, voluminous data, a big data, which is called as the large amount of data is called as the big data. That means if we can analyze this, if we can analyze this big data in a useful way, we can make a better decisions. But the human brain, it cannot sort this data in a short span. So that's why we are using the computers which are having the large amount of computing capabilities, what we discussed with in terms of the transistors. Which next, cloud computing offers a platform equipped with the vast computational, storage and networking capabilities. Here, software as a service, the machines as a service, everything are coming in the cloud computing. Internet of Things, IoT enables real-time machine-to-machine interaction by connecting them over a network and help establish a connected value. I'm going to discuss how the Internet of Things, how the machine-to-machine, how these are interconnected in the next slide. Simulation could enhance business operations by leveraging mathematical modeling, artificial intelligence, and virtual reality. Tomorrow, there is one more speaker called Dr. Prahalad Rao sir from the JNTUA is going to discuss much about how the artificial intelligence manufacturing industry. Next, collaborating robots. Our last three sessions, we focused on the robotic trends and what is the robot vision and all those things. Interconnected robots to facilitate the automation of manufacturing processes, helping improve efficiency. Next, so when all these components are interconnected by means of the web or this internet, at the same time, security also we need to provide. Cyber security, it is also one of the major tasks as well as the challenge. One more component of this industry 4.0, almost in our traditional or conventional manufacturing industry, only the physical safety or the machine safety. But here this is the cyber security by means of to establish secured communication protocols to ensure the data security. Next, system integration, machine to machine integration by means of this Internet of Things. Next, additive manufacturing or whatever the 3D printing, whatever we are calling it as. Almost today's morning session, one of the speaker had focused much on this additive manufacturing, how it helps. Additive manufacturing helps production in the small batches in a cost and time effective way. So I don't want to focus much on the additive manufacturing. So on the whole, this industry 4.0, so it is more than just a flashy catchphrase. It is a convergence or a confluence of all these trends and technologies. Industry 4.0 is not just one technology. It is the combination. It is a collection of all these technologies, all these technological trends, all these big data, cloud computing, Internet of Things, collaborating robots, cyber security, all these only in the past 1 decade we had witnessed. All these technological trends came into existence in the last 1 decade. So now the manufacturing sector, even the mechanical engineering is integrating our mechanical industry, our conventional factories, our mechanical factories with all these technologies. So then our mechanical factories are also called, slowly these mechanical factories were converted into the smart factories. Which are called as the industry 4.0. That means all these technologies made our mechanical factories as a smart factories, which are referred as the industry 4.0. The collection or the combination or the integration of all these technologies is called as the industry 4.0. Next, the Internet of Things. Internet of Things means the connectivity of the things. If we see the billions of devices which were connected on the internet from the 1992, almost 1 billion devices were connected. Slowly, as it is moving, now almost in 2020, 50 billions. In 2020, 50 billion things. Each one thing means one smartphone is one thing, one iPad is one thing, one smart tube light is one thing, one smart radio is one thing. So like this, by 2020, 50 billion things were interconnected. They are able to talk to each other. Even my smartphone and your smartphone. Now I am speaking over a Zoom from my house. My laptop is interacting with all your laptops or with your smartphones. That means these devices, all the devices now are almost 200 participants are attending this webinar, this faculty development program. So all our 200 smartphones or the laptops are interconnected through this Zoom now. So that means this is nothing but the Internet of Things. This is nothing but the Internet of Things. So now, next one is in brief, that means Internet of Things, industrial internet. Now only we are seeing the smartphones or the laptops interconnected. In the similar way, the mechanical facilities, all the mechanical devices or the machines or the devices, they too can be interconnected through the internet, which is called as the industrial internet. So this Internet of the Things, on the other side, cyber physical systems, embedded systems. By clubbing these two, it is nothing but the industry 4.0. As a result, we are seeing the smart factories. In the smart factories, it is a convergence of operational technology and the information technology. Operational technology, and the operational technology means our inventory, machinery, our production systems, our 4-bar mechanisms, or all these things. These are combined with IoT, cloud computing, big data, additive manufacturing, robotics, augmented, all these things already we discussed. By clubbing these two, application of cyber physical systems in the manufacturing, connected factories or the smart factories, it is nothing but the industry 4.0. This industry 4.0, don't just look at it is just a combination of these technologies. Because of this, this by 2025, this industry 4.0, it represents a new level of organization and the control of entire value chain across the life cycle of the products, up to the industry 3.0. All the manufacturing sectors, they were focusing much on the manufacturing facilities. But now in the industry 4.0 is going to focus on the life cycle of the products and individualized customer wishes. It is going to encompass all phases from the idea generation and the order to the development and production, delivery of a product to the end customer, even recycling and the related services. Because of the big data, because of the sensors, because of the interconnected internet of the things, as all the devices are interconnected across the value chain, right from the purchase of the raw material, right from the idea generation, up to the delivery of the product, up to the customer feedback, all that data by means of the interconnected devices, we can collect the data, we can integrate the data, we can use the data, we can analyze the data, and by means of this analysis of data, we can make an efficient decisions. As we are having the high performance computers within a short span, we can compute the data by means of the data science of the big data. We can develop a better decisions to meet the needs of the customer, customers. The key research areas: horizontal integration as well as the vertical integration. End-to-end engineering across the entire value chain. What I refer the value chain is nothing but the value chain refers complete everything, all components of the right from the human resources, public infrastructure, tools and fixtures, enterprise infrastructure, raw materials, machinery, factory infrastructure, supply chain management, global infrastructure, customer relationship, engineering design tools, everything right from the raw materials up to the delivery of the products, as well as the customer feedback, customer requirements. So this industry 4.0. Now, because of this industry 4.0, this is, if we look at this here, this conventional factory, it is a fixed, rapidly, rigidly sequenced car manufacture on your production. A one line of assembly. It is going to change here is the industry 4.0, decoupled, fully flexible, and highly integrated. These machinery, these are all intelligent, which are interconnected by means of the communication devices. Whenever one production facility became idle, then it interacts with the another one, then automatically it takes the raw material and it starts working. So this is called as the flexible integrated manufacturing system. Still, if you go into the deeper, this is the raw material supplier, this is the end customer, this is the line of assembly. We are keeping various sensors to measure the data. Here we are keeping sensors at various manufacturing points. For each and every machine, we are keeping some sensors. These sensors collect the data, and this data is stored, data storage. Whatever this data, it will be uploaded to the cloud. Whenever the data is uploaded to the cloud, it can be accessed by any person who are connected with this manufacturing or with that factory. So by using this big data and cyber security, these two are the interconnected. This data will be used by advanced manufacturing systems or cyber physical systems. This cyber physical systems, by using this data, these autonomous robots, they use this data and they start working on this autonomous vehicle, flow optimization, increased security, lower cost, and also 3D printing, additive manufacturing. This also can collect the data, can use the data which is stored in the data storage devices by means of the cloud. This means all these devices are interconnected and they are connected to the cloud where the data is stored, Once again, to analyze this data, we are having the big data techniques or the data science techniques or the algorithms or the machine learning, robot vision, computer vision, deep vision. All these are once again is a separate field. So now, even up to the customer, mass customization. So this is how digitalization automation, connectivity, analytics. These are all interconnected in the industry 4.0. All these elements, they talk to each other. That means Internet of Things. Here, only all these are the non-living things. They are all interconnected. They are talking to each other. Now that means now we are moving from today's factory to industry 4.0. What is the today's factory? At the machine level, we are using various sensors and actuators, programmable logic controllers, SCADA, supervisory control and data acquisition. At the cell level, manufacturing, execution system. At the process and control level, enterprise resource planning. At the factory and operational level. Slowly, it is what we are now. Almost 50% of the industry are using this structure of the automation. Now we are moving towards this industry 4.0 factory setup or the smart factory setup via big data, cloud computing, Internet of Things, additive manufacturing. These are the technology levers of the industry 4.0. Now that's why I think there is a less amount of time, so that's why I could not able to focus much on this. So here, component level, machine level, production system. Here, the data source, sensors. At the machine level, controller, networked systems. Here, in the today's factory, smart sensors, we are focusing on the precision. But here's this components, the same sensors are self-aware, self-predict. Here we are focusing on the fault detection. Here in the industry 4.0, we are focusing on the degradation, monitoring, and remaining useful life prediction. On the production systems, we are focusing on the productivity. Here, worry-free productivity. Still, the traditional manufacturing to the industrial 4.0 manufacturing. Here, the process. Here, rigid and manual. Here, agile and automated. Here, product, standardized. Industry 4.0, personalized and customized. So just I would like to focus a couple of minutes on how it is personalized means. Now here, suppose if you would like to get our shirts stitched or that there are ready-made and personalized. If you go to any shop, the sizes are XL, XXL, XXL or 40, 42, 44 like that. But some of the human body structures, this 40, 42, they may not suit. Then if we use these robots or something else, if our body is exposed to a thermally visioned robot, it can measure our complete body dimensions. By means of our body dimensions, it can take the measurements and it can automatically give the instructions to the automated tailoring machine to cut the cloth and to stitch the cloth to suit our physical body. That means from the ready-made shirts to personalized stitched shirts. That means just I'm using a common example here. So that means we are moving from standardized product to personalized and customized products. Scale of factories. Large factories at the centralized locations, small factories at decentralized locations, but small factories, they are all interconnected, well interconnected by means of the communication devices. Supply chain, stock-based planning, dynamic and predictive, low cost, high efficiency, high return on the capital employed. So client relationship. Next, I don't want to focus much on this security and safety, which is completely the cyber security professionals. But however, as for this, even for our smart factories, we need the cyber security at 3 layers. At the application layer, safe and secure industry 4.0 processes. At the system layer, all our smart secure cyber physical systems. And the technology layer, which is not visible to the eye. Safe and secure things, safe and secure data, safe and secure services. Sorry, there is a typographical mistake here. So at the application layer, at the system layer, at all the 3 layers, we need a strong security protocols. So why this industry 4.0? As all we know, shorten the time to the market, increase the flexibility, boost efficiency. Still, why this industry 4.0? Faster production, better quality, increase in productivity, sharing economy, improved decision making, mass customization. See, if a small one in the Siemens factory by means of the 4.0, number of defects per million units in 1989, it was around 500. But as in the introduction of the Industry 4.0, almost only 12 number of defects per million units because of the smart factory. How they improved a lot in terms of the quality. It is just, I'm giving only one example for the better quality here. And next, in almost all the industries, Siemens, Trump, General Electric, all these companies are introducing this Industry 4.0. This Siemens factory, this is Siemens, a German manufacturing giant, artificial knee and hip joints. Previously, they were producing the standardized products, but now with the smart factories, with the new software and steering solutions, this enabled the Siemens to produce an implant within 3 to 4 hours. That too, which is mostly suitable to a person. This artificial knee and hip joints. A Trump, which is a German tool maker, an Industry 4.0 supplier. Each component is smart and knows what work has already been carried out on it, because the production facility already knows its capacity utilization and communicates with other facilities. Production options are automatically optimized. Similarly, here in the General Electric also, it is having its own operating system, predicts industrial operating system, which is for the industrial internet, is powering digital industrial businesses that drive the global economy by connecting industrial equipment, which is called as the Industrial Internet of the Things, IIoT, Industrial Internet of Things, analyzing data and delivering the real-time insights. Predicts-based apps are unleashing new levels of performance. So now, and also I would like to focus a little bit on the Industry 5.0. Just slowly, the industry is speaking now 5.0 also. Now, as already we discussed Industry 4.0, Industry 1.0, Industry 2.0, Industry 3.0, Industry 4.0. Here, these are all the cyber physical systems, But the Industry 5.0, it is nothing but the interaction between the human and machine. In the 4.0, the interaction is between machine to machine. Here, the Internet of Things is between machine to machine. The machine to machine are interconnected. But in the 5.0, the interaction and collaboration between man and machine are going to interact with each other. But in the Industry 4.0, machine to machine interaction only. But in the 5.0, mass customization and cyber physical systems. Mass customization, here cognitive computing. Here in the 4.0, only artificial intelligence. That means the machine, we are injecting the artificial intelligence to a robot or to a machine. But here cognitive computing means a machine or a robot, it can think just like a human being. This is called as the cognitive computing. It can make the decisions on its own. Human robot co-working with the machine. This is called as the Industry 5.0. That means here, but in the Industry 5.0, the skill level of workers and operators would be challenged, leaving them with providing value-added functions to the production process. And still, if you focus a little bit more on this Industry 5.0, I think that there was a prediction by the International Federation of Robotics from 2020 to 2022. Almost 2 million new units of industrial robots are expected to be installed in the factories around the world. Now, in the morning also, one of the speakers have shown the same slide. This is the Industry 4.0, where the worker and the robot, they are working in the same place. But here, robot and worker both active and in the workspace, and the movements are sequential. But in the Industry 5.0, robot and worker work on the same part. They work on the same part at the same time, both in motion. And also, robot responds in real time to the movement of the worker. This robot, it understands the movements of the worker also in synchronization with the human being, the robots. That means this is called as the responsive collaboration. That means human and machine interaction. This is how this is going to be. That means still in a broader sense. This here, the human being is working on a machine. The robot is observing. The robot is observing. But this robot is backed up by this cloud computing or the big data, whatever the data. The cobot is nothing but collaborative robot. It is making the decision. Shall I help with the task? It is thinking on its own. With having the huge amount of data, with the image processing, audio analytics, how the human body is responding. This means this is other sensory data, which is located human. This big data, it is storing the data about human intention analysis plus observe 360 degrees, audio and other sensors, machine cognition. Machine cognition means the machine is thinking on its own. On the whole, it is having its decision-making capability, and it is having a capability to interact with the human being, to support the human being. So slowly, that means from the information society 4.0 to 5.0, here, this with the cloud space, cyberspace, and physical space. There is a clear-cut boundary. There is a clear between cyberspace and the physical space. In the space 5.0, these boundaries are erased. This science and physical space, there are no boundaries. They are almost interconnected with each other. These machines are the integral part of the human life. They are the integral part of the industry line in almost the close coordination with the human being. Almost that there was a prediction that in 2050, an estimated 40% of the population will be 65 years and older in Japan. People in Japan also call it as a super aging society. As the more number of aging people are there, these collaborating robots, they are going to help the humans in their daily activities. They are going to support, they are going to assist, they are going to help in our houses, just like as if they are our friends. So that means almost industry 1.0 to industry 2.0, 120 years. Up then by the next 70 years, 3.0. In the next 30 years, 4.0. In the next 20 years, industry 5.0. That means fastly, this the technology is advancing. Now the impact of this, the ranking of the industries affected by the industry 4.0, virtualization, level of value added. Now almost here, if you see this, machinery, printing industry, electronics industry, electrical engineering, automotive, original equipment manufacturers, other vehicle manufacturing, rubber and plastic parts, metal parts, furniture, that means paper industry. All these industries are slowly moving towards the smart factories. Smart in the industry 4.0. Clothing, wood, chemical products, metal working, metal machining, beverage industry, almost everything is moving from the conventional mechanical factory to the smart factories. They are going to use these cyber devices. Now, if we see the digital enterprise, I'm going to give you some examples how these cyber physical systems are using. The entire value chain is digitized and integrated in the Siemens factory. You see from the simulation, from the product design up to the real world, everything is digitalized. Industry 4.0 or industry 5.0, you see from the product design, production planning, production engineering, production and services. You see at the starting of the product design, simulation. Next, product life cycle management, from the product design to the service to the customer. Next, manufacturing execution system, right from the production planning to the production, complete manufacturing execution system, total integrated automation, life cycle and data driven service. Everything is digitalized by means of the cyber physical devices. The complete value chain is digitized in the Siemens smart factories. They are using product life cycle management, manufacturing execution system, total integration automation. completely in the industry 4.0. Siemens collaboration platform, they're having their own software team center or NX, systematic IT, semantic or numeric. Once again, under the same Siemens design and virtual production, at the design side and the virtual production side, they're using the software NX, Team Center, and Technomatics. On the real production side, Semantic IT, Sematics S7, they're using all these softwares to control their pre-production and real production side. Still, on the plant side, on the production side, Siemens plant cloud services, plant analytics, as well as the plant security. That they're having the complete, total integrated automation, complete the manufacturing execution system is digitalized. Similarly, if you go to the ABB, they too have digital enterprises, digital on the device, digital on the edge, and digital in the cloud. Completely digital quality management, digital operations, and that means complete mechanical factories are becoming the smart factories nowadays. If you see the complete ABB, complete value chain is getting digitalized. And also, if you see the ABB, how they are moving from automation to the autonomous, right from the muscular power to the muscles, nerves, senses, brain, hands, up to the artificial intelligence. They are moving from the muscular power to the artificial intelligence, motors to the cyber physical solutions, copper and iron, electronics, automated operations, digital operations, autonomous operations. Now, from autonomous operations to the collaborative operations in the industry 5.0. This slide, it is only for the industry 4.0. In the industry 5.0, it goes to the collaborative operations. Which is nothing but industry 5.0. So that means completely smart factory facilities in the ABB. Still, if you look at it, what is the industry 4.0 or industry 5.0? The augmenting the humans with artificial intelligence. You see the big data technologies and machine learning algorithms plus computing power with multi-core technologies, multi-core processors is nothing but the artificial intelligence. Big data, algorithms, what we are calling it as the machine learning, and computing power, multi-core technology with more number of transistors with the enhanced computing power is called as the artificial intelligence. This complete artificial intelligence, it is going to support the human, amplifying the human potential, the human being with artificial intelligence, human artificial intelligence, experts supported by the algorithms, amplifying the human potential. It is going to the industry 5.0, whatever we are referring. So in the same HCL, you see what are the components the HCL is using, completely whatever we discussed already: robotics, data analytics, manufacturing automation, 3D printing, manufacturing IT, cyber security, and virtual reality, artificial intelligence. Already we discussed it. The HCL is already using all these things in their industry, and also some more in solar, in the wind power. This Vestas, it is also using how many thousands of sensors. The data from the thousands of the sensors they are using from all the field, from the field level also it is collecting the data by using the big data techniques as well as the machine learning techniques. It is sorting the techniques and is making the better decisions. So, but with this one more, I think almost the last we are coming to this thing. But though we are having a lot of advantages, what are the factors hindering the spread of the industry 4.0? The cultural market, there is a distrust, uncertainty, lack of demand for continuous learning, At the same time, labor market obstructing the fact. That means these are hindering what are the factors that are blocking the industry 4.0? Shortage of the quality workforce, old-fashioned training, and also organizational obstructing factors, lack of digital strategy, risky investment means lot of investment is required, fear of loss of control over intellectual property, failure to develop the data-based services, lack of senior management support. and also some technological factors are also obstructing the industry 4.0, expensive technologies, lack of standards, security of data, uncertainty regarding the level of encryption, develop data analysis. And coming to the India, steps taken by the Indian government to promote the adoption of the industry 4.0 national manufacturing policy. In July 2017, the Indian government rolled out a new policy to push the manufacturing share to 25% of the GDP by consolidating Make in India initiative with the focus on adoption of the digital platforms for industry 4.0. National program on artificial intelligence. In the Union Budget 2018-19, the government of India announced that the Niti Aayog will create a roadmap for national artificial intelligence program, focusing on developing the new artificial intelligence and also the mission on cyber physical systems. In the Union Budget 18-19, the Department of Science and Technology launched CP, Cyber Physical Systems mission to support the establishment of robotics, artificial intelligence, digital manufacturing, etc. And also the industry, the Center of Excellence on the IT for Industry 4.0, it is also established to push the Industry 4.0 in India also. So these are the some things. So let me see the question and answer session from my side, whatever. So here, the first question is, how much we are suffered due to the industrial evolution? Is it affecting in nature in a quicker way? Are we losing the nature resources quickly? As it is really a right question. As you rightly said that though it is affecting the nature, as you see, this technological industrial revolution, there are, if you take some 2 to 3 examples, on the World Trade Center in the America, World Trade Center, the twin flights attack, and also on the Nagasaki, Hiroshima, there was a bomb attack. But this bomb attack or the aeroplanes, they are not produced for the negative. Only the human beings are using it for the destruction purpose. That means the industrial revolution, the technological advancements are towards for the betterment of the human life. But the 1% or maybe the less than 1% of the people, less than 1% of the people are using these technological advancements for the negative side also. Whatever the means the nuclear power, it has been developed with a positive thing towards the betterment of the human life. But the same nuclear power is used for the destruction also. So that means it is in the hands of the human being how to use these technological advancements, whether towards the positive or towards the negative. So the second question is, good evening. What about DCNC developed by IITB a way back? Illustrative session and informative. So really, I don't know much about the DCNC developed by IIT Bombay, but I thank you for your feedback on illustrative session and informative one. Sir, it is over.
Two persons have raised their hand, sir, to talk with you now, sir. Shall I allow them, sir, to talk with you?
Yes, sir, please, sir.
1 minute, sir. Dear Ashok Reddy Garu, now you can talk with the speaker now. Ashok Reddy Garu. Hello.
Sir, please, sir. Sir, please, sir.
Ashok Reddy Garu. Ashok Reddy Garu.
So there is a question now.
Ashok Reddy Garu.
Question and answer session. How industrial revolution affects on education? Sir, it's a very right question, sir. Mr. Raghu asked this question. As the education institutions are there to provide skilled manpower, education institutions are meant to for the development of the skilled manpower. As and when there is a technological advancements, as and when there is a new industrial revolutions, the education institutions should gear up to meet, to impart this new technology to its students. And also all the faculty members, they have to gear up to imbibe this new technology. That's why we are having all these faculty development programs to get acquainted, to get trained in the emerging technologies. Always in the society, in the industry, there is a technology. Always there is an advancements in the technology. As and when there is a new technology, we have to learn the new technology. That is the basic purpose of this FDPs also. Even we are conducting this FDP on the emerging technologies in the mechanical engineering. Its main aim is to equip the faculty on the emerging technologies. Definitely, whenever there is an industrial revolution, the educational institution should gear up and it should get acquainted with the new technologies. It should impart these latest technologies to the students. The educational institutions have to produce the right manpower, the skilled manpower to the changed industry requirements from time to time. So am I right, sir? I hope I have given the answer to this, Mr. Raghu.
Yes, sir.
One more person is ready to talk with you now, sir.
Sir, please, sir.
Sandhi Rajshekar Garu, just you can talk now. Just now I enabled you to talk with the speaker now.
Sir, Rajshekar, sir, please, sir.
Sandhi Rajshekar Garu. Hello, Sandhi Rajshekar Garu. Okay, sir. Thank you, sir. He is not able to talk with you now.
Okay,
Yes,
sir.
sir. Yes, sir.
Yes, sir.
Shall you ask participants to send their
Yes.
questions via email? Yes.
Okay, sir, please, sir.
Yes, sir. Yes. Now I request our
I have-
participants, if you people have any questionnaires or anything, any doubt you want to share with our professor, you can send our through mail ID. Okay. Now it is time to thank our beloved principal for his wonderful, more inspirational and technological oriented talk. Really, Professor, on behalf of Vemu Institute of Technology and our participants, I thank you very much in this
Thank you,
wonderful for the speech which you have given. Really, your speech definitely we have all understood how the olden technology has been transformed into a new technology, and also how these transformation of the olden technology, new technology is very much important in the coming scenario. And all we have really understood, and definitely your speech would have made all the participants to think or to start a research start with the research on these smart technologies. Definitely your speech have given more inspiration to us, Professor. Finally, once again, I thank you on behalf of Vemu Institute of Technology and our participants for the one excellent speech which you have given on technology trends and Industry 4.0. Thank you, Professor. And finally, thank our all participants with which the passionately you have listened this wonderful session. Thank you all.
Thank you, sir. Thank you, sir. Thank you, sir. Thank you,
Thank
sir. Bye, sir.
Dear participants, still you have any queries, you can write your questions through this email ID. Thank you so much for your active participation. Thank you.
Shall I leave?
Yes,
Ma?
sir. Yes, sir.
Thank you. Thank you.
Thank you, sir.